punch him in the neck. No, just punch him right here.
Hello and welcome back to Calculus 2, section 6.8 on logarithmic and exponential functions. Now we are relating this to calculus. Before I do anything, I will remind you that number e is defined as the limit as n goes to infinity of 1 plus 1 over n to the n. So
switch the screen whenever you want.
this is the definition for number e. You guys are terrible. If the stream stops at any point, that means I just left. So number e, this definition is about what, 250, 300 years old, something like that. I have to take a look and date this. So that's the definition for number e. And now I can have e to the a as limit n goes to infinity of 1 plus a over n to the n. So that's one way that you can gain the exponent on e. Or you can have, let's say, e to the b as the limit n goes to infinity on 1 plus 1 over n to the bn. All right? So these are the two ways in which you are gaining the exponent on e. And this is going to be used a lot later in chapter 8. So make sure that you know all three of these forms, because either a or b will create the exponent on e. So technically, if you have limit of 1 plus 3 over n to the n, your answer is e to the 3. Now, this limit can be done using L'Hopital's rule, and you can prove all of these things. We are just actually reviewing, so I just wanted to toss these formulas before we do anything else. The next in our definition pool here is the definition for ln of x. So ln of x is defined as 1 over x as the derivative is the integral of 1 over t dt. Now, we have to specify that this only works for x's that are larger than 0. And so this is the official definition, and I will go back to Calculus 1 to write some of the stuff. So in Calculus 1, you learned that the derivative of ln x is equal to 1 over x, and then you walk away. The next one you learned is that the integral of 1 over x dx is equal to ln absolute x plus c. And when you look at these two, you might be wondering, why do I have absolute value here, but I don't have it in here? Well, we all agree that this is the left-hand side as an input of the problem, and then you have the answer on the other side, right? So this is where you start. So if you observe, actually what I'm going to do is, no, hold on. I'm going to move this here, and then fix this integral into a better integral. There we go. And I'm going to just split the space so I can actually explain underneath. It's much easier. Now, whatever I write underneath, you can write on the side if it's relevant to you. But look at this. The domain on ln x, domain on ln x is just positive x's. So the only numbers that you are allowed to use in your input side of this equality for derivatives are positive numbers, right?
Pretty good.
Now, if you look on the other side, you have both positive and negative. Now, these guys will never be used because nothing maps into them. But having extra in the range, no harm's done, right? Now, observe what happens here. Your input has both negative and positive numbers allowed as input. Without absolute value, your range would only be this. So all of these numbers would have nothing to map into. But with the absolute value, you are gaining another branch. So now positive and negative numbers have somewhere to map. You see that? So that absolute value there is not there for decoration. It's there because we need to make sure that whatever numbers you are allowed to plug in on the left side, you're also allowed to plug those numbers on the right side. And that absolute value fixes the issue of domain and range for our integration part. Now, the definition given to us in a textbook for ln function does not have absolute value on this side, but it does have this restriction that we are only allowed to use positive x's. And in that case, everything works, right? If you restrict your stuff to that. Now, the rest of this is the rest of the ln part is remembering the formulas which you guys learned long times ago, and then proving these formulas for whatever reason using integrals. So the properties that you might or might not remember from your previous life, like ln xy is ln x plus ln y. Another property that says ln x over y is ln x minus ln y. Number 3, ln x to the p is p ln x. What else do they have? They have the derivative and the integral. I don't know why they have this, but I have that one, I have that one. So I have the rest already. So these are the properties of ln. So now this allows us to integrate using u substitution some of the problems that might not look like they are ln until you do substitution. For instance, integral of, say, x divided by x squared plus 9 dx. So the integral here is done by using u sub on the denominator. So you have x squared plus 9 in the denominator. Du is equal to 2x dx. I need this 2, so I'll put 2.5 in front. And now, no coughing, is 1/2 integral. 2x dx is du, and divided by u. So this is 1/2 ln absolute u plus c. And then we go with, I don't care about u, I care about the x. That's ln of x squared plus 9 plus c. And we are done with this problem. So nothing told us that it's a ln problem when you look at it, right? But the trick is that if you have a derivative in the numerator is derivative of the denominator, then immediately you know that you can have the substitution and work this way, right? So now this allows us to figure out, let's say, yes?
Is there something special about the a squared plus b squared in the denominator, or?
Actually, it will be. When we reach chapter 7, there will be other ways to deal with this problem. So the answer is yes, but right now, no. Anything that I can put together that will have the derivative in the numerator and denominator. So let's say the integral of e to the x divided by e to the x minus 7, right, would be another one. And you can try this one for a few seconds.
But that says something good.
You asked
You
about
don't say
the math
bad,
problem.
you say pretty good.
Uh-huh.
So it's like slow when something's bad, but when something's good, you don't say
Slow
bad.
means it's not happening right now.
Slow.
You trying to
I think
come
slow
with me
means like literally like slow down.
Nah,
No.
slow means
Slow-
it's like
I know.
not
I
happening.
know. In context, you can tell me you can't like you're like crazy.
You're like crazy, man. Legend. Legend. Show me the psychologist.
You know, ask the doctor.
I have nothing to do with Dr. Robin.
You're crazy.
Me?
I guess this problem is way too easy because the party already started. So u equals e to the x minus 7.
U equals e to the x. Uh-huh.
So integral of du over u, which is
ln.
absolute u plus c, which is ln of
We care about x, not u.
exactly, plus c. So it's just x plus c.
Whoa. Whoa.
Nah,
It's absolute value of EDX minus 7.
yeah, minus 7.
Good. Just want to see if you're paying attention.
Otherwise, it would have just
Absolute
been
value though.
Those are
It's parentheses. What's going on? You might have to call it a day.
I also want to make sure that your OCD is at the level that you need to make through this class. So very good. So I tested you twice. You passed both of those. Now we have another question. Yes?
Yeah, so
Can those go towards the thing?
do you care if the plus c is a plus k, or
Whatever. Plus A, B, C, K, whatever. Whatever.
That's $1.
Wait, what
Who's
happened?
the first one to opt? The narc.
Is that...
Oh, it wasn't just me. I said, oh, because it's just variable.
All right. This class is getting... I guess, well, we have properties of e to the x, and I think we're done for, let me see. Oh no, we have one more. Okay, so now I already wrote down the definition for number e. Now, if you use number e and create exponential function as e to the x, we can use basic properties for exponential functions where e to the x plus y is e to the x times e to the y, e to the x minus y is e to the x divided by e to the y. Number 3, e to the x raised to some power p is e to the x p. Then we have ln of e to the x is equal to x. This is because they are inverse functions. And finally, e to the ln x is also equal to x for all x is larger than 0, right? Domain issues. These two in the back, so this one and this one, I'll just say inverse functions. because a logarithmic function ln of x and e to the x are inverses of each other. Now, in terms of the derivative, when we are dealing with the derivative, we need to worry about the chain rule. So the mostly used derivative formula is that the derivative of e to some function of x. So it's not just e to the x. It could be e to the sine x. It could be e to the x squared minus 7. So whatever you come up with is always going to be e to the f of x times, very good, derivative of f of x. Excellent. So that is our chain rule formula, which is used, I would say 99% of the time you see exponential function is going to be e to the sum function. And you're done. What is the derivative of e to the pi?
E pi times the derivative of pi, or the pi.
Zero is a constant, by the way.
Listen.
So, yes, e to the pi is constant. So the derivative of e to the pi is 0. Nice. All right, great.
God loves five. I love all these.
Wait, what's his name?
Daniel.
Oh, okay. So now,
Quietest tone.
Narc. Just creeped up here.
now, not every exponential function is e to the x. Some of them might be 2 to the x. You might have 2 to the sine x, and we would like to see the most general case that you can encounter. So the most general case, would be the derivative of b raised to the f of x. So you are allowed to have any value as a base, not just number e, but any value, and you can have any function. So you can't be more general than this. And the derivative for something like this is, again, you copy b to the f of x, you multiply that by f prime of x, and finally you multiply by ln of b. So that would be the most general case to find the derivative of exponential functions. Now you can see that if b is equal to e, then on the other side you just have, it collapses to the previous formula, because it will be e to the f of x, this would be still f prime of x, and then you have ln of e, but ln of e is 1, right? So it collapses to the previous formula. An example for you to enjoy. So what is the derivative of 3 raised to the cosine of x? Three cosine x? Okay. Negative sine x. That's good. Times ln 3. Very good. And that will be the full derivative of the thing. See you Monday.